The table below shows corresponding values of x and y for y equals the log equation. Okay. The values of y are given to two decimal places as appropriate. So we're given some values of x and they've already computed the values of y using this equation up here. Now, using the trapezium rule with all the values of y in the given table, obtain an estimate for this integral, giving your answer to one decimal place. Okay, so essentially, guys, we just got to use the trapezium rule. So whatever you guys do, don't attempt to integrate this problem. If you do that, you wouldn't actually get a mark. So yeah, let's avoid that. Now, to use the trapezium rule, the formula is a bit like this. We have a trapezium rule t, and we say that it's approximately equal to the change in x, so they use h in their definition, over 2, and then we're going to multiply all of this by a big bracket, and in this bracket we're going to have the first term of y plus the last term of y, so we call this first plus last, and then it's going to be plus 2 times the sum of the middle terms, so middle terms. Okay, this is just how I personally write it, and I prefer to write in words at times, especially when the formula is a bit confusing. So essentially, guys, we're just going to pop in all these values here. So we say that, okay, by the trapezium rule, we can see that the change in x is pretty much the gap between each x value. And as we can see, it's going up in more or less 3s every time. So we say that the change in x is just 3, and then it's over 2 times the first term, which is 2 for y, plus the last y term is 4.81, plus 2 times everything in between. And by between, we're talking about these values here, yeah? So it's going to be 3.32 plus 4 plus 4.46. Okay. And then we just put that all in the calculator. And once you put that all in, they want us to round your answer to one decimal place. Now, before you do that, guys, it's always a good idea to actually write the full answer first, yeah? So according to the full answer, we should get 45.555, and to one decimal place is 45.6. Yeah, and that's A done. Now it says, using your answer to part A and making your method clear, estimate the following two integrals. Okay, so for the next two integrals, the trick behind this is that we need to kind of rewrite the log bit into this upper part A log expression. Okay, so let's have a go at that, yeah? Now just focusing on the log 2 4x squared bit. So I'm going to write that here. So part BI, we got log 2 4x squared. And now using some kind of tricks, like in order to get this 4x squared into some kind of 2x expression, you might notice that these two are actually squares of 2x. So what I'm trying to say here is that this is pretty much identical to log 2, and if you put a big bracket, we're going to have essentially 2x all squared. Okay, that's exactly what it is. And now one of the interesting properties of log is that if you've got a power inside the log, this power goes in front of the log term. So this is actually now just 2 times log 2, and then you're just left with 2x. So yeah, so actually all of that just becomes 2 log 2, 2x. So if we put this all back into the integral and just take this 2 and this 5 behind integral, so guys, when you've got constants like 2 and 5, they have no effect in integral, so you can put it behind. You're essentially going to have now 2 over 5 and the integral of, well, the rest of this, 2 to 14 of log 2 2x dx. And well, we know what this integral is. We just evaluate in part A. We actually got 45.6. So that means the answer is going to be 2/5 of, but it's always better to use a full answer, yeah? 45.555, and then put this in your calculator. It should be estimated to about 18.2. Okay? Now, for the second bit, it's kind of the same idea. So let's just copy out log 2 over x for a second, yeah? So for part 2, we're going to have log 2 over x. And once again, the main idea is to always kind of insert the 2x into this. So we need to somehow rewrite 2 over x as 2x in some capacity. And unfortunately, there is no clear way, but the best way to do it is to actually multiply up and down by 2. Because if you multiply up and down by the same value, it's like multiplying by 1, so nothing necessarily changes. So let's just do that for a second, yeah? So multiplying up and down by 2, we're going to have essentially 4 over 2x, which is identical, they're the same fraction. But now we're going to use another feature of the logs, which is if you divide some terms inside a log, is the same as subtracting log terms. So what this means is that we now have log 2 of the 4 term minus log 2 of the 2x term. And now log 24 is just a value you can just put in your calculator, or you can just guess it, or just know it. The actual value of this one is in fact 2. And then this log 2x, well, that's exactly the form we're looking for. This is the form we want from the previous questions. Now all we can do, guys, is just put this into the integral sign. So it's going to look something like this. We now have the integral from 2 to 14 of 2, and the good thing is when you plus or minus, you can separate the integral terms. So it'll be the integral of 2 take away the integral of this. So integral 2 dx minus the integral of 2 to 14 of log 2x dx. Okay, so that's good so far. Now integrating 2, well, that's not too bad. It's just essentially, well, if you integrate any constant, you just get an x, so it'll just be 2x, and then you just apply the limits from 2 to 14. And all this means is that you first plug in, replace x of 14, so you're going to get 2 times 14, which is 28, minus, and then replace x with 2. 2 times 2 is 4. So this value is just 28 take away 4, which is 24. And well, for the second bit, we know what that is. That's from part A again, which is 45.555. So we just put that in 2. So 45.555. And then therefore, we just say, okay, subtracting these results, 24 minus this value, and again, rounded to 1 decimal place, you're going to get a result of minus 21.6. And that's your one done. Okay, question 2. One of the terms in the binomial expansion of 3 plus ax all to the power 6, where a is a constant, is 540x to the power 4. Okay, find the possible values of a. Now, for this question, and interestingly for all the binomial expansion questions, the best thing you always want to do is always try and expand this as much as you can until you get to x to the power 4. Because the main idea is to pretty much equate this to some term over here. So the way I'll do this, guys, is this. So I would firstly write down the binomial expansion formula here. And the way I personally do it is I always start with a summation sign because it just feels natural. And because we know we're going up to the power 6, we always begin at n equals 0 all the way to the power 6. Now this is just a case of order, yeah? The first term should always be this symbol, which is 6 choose n, where n is pretty much your number of terms. The next part would be the 3, yeah? So it'd be 3 to the power of 6 minus n, yeah? So you're always kind of going back here. And finally, you got the ax, which is going to be ax to the power of n, and that's your current position. So let's go ahead and expand for a second, guys, yeah? And try and do it in the easy way possible. So we start from n equals 0. When you plug in 0, you're going to get 6 choose 0, and then 3 to the power of 6 minus 0, which is just 6, and then ax to the power 0. Okay, we can just leave in this form now. And then we do the next set. Replace n with 1, we get 6 choose 1, 3 to the power of 6 take away 1, which is 5, and then we got ax to the power of 1. And you probably realize that if we keep on doing this, you know, we're going to do this for a bit, we'll eventually get down to the fourth one, right? X to the power 4. So let's just put dots there until we get to 6 choose 4. We're now going to have 3 to the power of, well, if we think about when n is 4, 6 take away 4 is 2. And we got ax to the power of 4. Okay, and again, this will keep on going until you get to the final term, which is 6 choose 6, 3 to the power of, well, 6 take away 6 is 0, and then ax to the power of 6. Okay, so just ignore the other terms. Now, because they want us to match, what is it, some term which is x to the power 4, we're actually looking at this term right here. And if you were to put this in your calculator, 6 choose 4 times 3 squared, you'll get a result of something like this. You'll get 135, and then you can just expand this little bracket. You get a to the power 4, x to the power 4. Okay, and now just looking at this carefully, you got 540 x to the power 4 and 135 a to the power 4 x to the power 4. So just pretty much equate them, yeah? So they're saying the coefficient of this x to the 4th is just 135a to the fourth. So guys, what I'm trying to say here is that the 135a to the fourth, it must be equal to 540. So 540. And that's it. And then you just rearrange this and solve. So what I'll do is divide 135 across. So you get a to the 4 equals 4. Now this is the part where you gotta be careful, yeah? Because unfortunately you can't fall through and get a proper answer. Because I think what they don't explicitly tell you to find it in exact form. You could just find a fourth root, but I'll do it step. I'll find the square root first, guys, because we know if we square root both sides, you get a to the squared equals 2. And if we square root this again, you're going to get a equals plus minus root 2. And that's your two solutions of a, plus minus root 2. So now looking at b, it says hence, so this means continue from the previous. Find the term independent of x in this given expansion. Now they use the term, the phrase independent of x. What that means is that if you had to expand this fully, all you care about is the terms that have no x attached to it, yeah? And you can see that there's not going to be many terms because practically almost everything, except the first term, because ax to the 0 is just a constant, is nothing, has an x term. So all of these have an x term except the first. But another thing to note here, guys, is that we have x to the 6. And the only way to pretty much cancel this term is to times it by itself, which is another x to the 6. So let's just write this down for a second, yeah? So for part B, we got 1 over 81 plus 1 over x to the 6. And they want us to multiply against our binomial expansion, right? So instead of this term here, we're going to replace all of this with what we found over here. This kind of chain, yeah? And I'm going to quickly just evaluate this, guys. When you got the first term, 6 choose 0 times 3 to the 6, that's just going to give us, all of that will just give us 729 plus the second term in the series would be this one here, 6 choose 1, 3 to the 5, and ax. Evaluating all of this, guys, should give us 1458 ax. And well, if we keep on doing this, yeah, plus dot dot dot, we're eventually going to get to the final term, 6 choose 6. And if you put all of this in, well, this gives you 1, this gives you 1, so 1 times 1 is 1. Ax to the power 6 is just a6x to the 6. Okay, now let's see what's next here. So using the normal expansion method, we'll have to multiply term by term. So you basically do 1 over 81 times this, and 1 over 81 times the next one, and so on. But we're not going to do that, guys. What we're going to do instead is multiply 1 over 81 with 729 only, because if we multiply this with every other term, we're going to get an x. And we're going to multiply 1 over x to the 6 with the final term. Again, this x to the 6 will cancel with this x to the 6. And if you do that, guys, you're pretty much going to get an answer of, well, 1 over 81 times 729 will give us just 9, plus, and just ignoring the rest of the terms, if we go straight to the last term, 1 over x to the 6 times this would just give us a to the 6, because x is cancelled out. And that's it, guys. And then we just say, okay, all we care about is 9 plus a to the 6. And we know what a was, yeah? We said earlier that a was plus minus root 2. Let's just choose root 2 for a second, yeah? And if you plug in root 2 here, you're going to basically get 9 plus root 2 to the power 6. All of this is literally going to give us, in your calculator, a 17. And that's it, guys. That's your question done. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.